आइए हम सुने विज्ञान की अनकही कहानियाँ। आइए हम सुने विज्ञान की अनसुनी कहानियाँ। एक नई दुनिया की आवाज आपकी आवाज, विज्ञान की आवाज, की आवाज।
Celebrating Azadi Ka Amrit Mahotsav, we bring you all a podcast series on STEM popularization. That is, science, technology, engineering, mathematics, and medicine. Supported and catalyzed by the National Council for Science and Technology Communication, the Government of India. Program is produced by Media for Community Foundation. Creative content and technical support is given by Farzeen Sultan.
एक नई दुनिया की आवाज आपकी आवाज, विज्ञान की आवाज, की आवाज, की आवाज।
साइंस की दुनिया एक ऐसी दुनिया है जहाँ हमेशा नया इनोवेशन होता है। आज हम सुनेंगे पुराने ढूंढे हुए सितारे, उनकी कहानियाँ और उनका राज खोलने का एक नया तरीका। हाँ, आपने बिल्कुल सही सुना, हम बात कर रहे हैं गैलेक्टिक आर्कियोलॉजी की। आप सोच रहे होंगे कि ये क्या है। गैलेक्टिक आर्कियोलॉजी का मतलब है हमारी गैलेक्सी के अंदर छुपी हुई कमियों को समझना, उनका पता लगाना और उनकी कहानियों के जरिए अपने आज और कल को बेहतर बनाना। ये एक ऐसा साइंस है जो हमारे स्पेस की पुरानी राहों को खोजता है, उन सितारों के थ्रू जो हमारे लिए एक खोया हुआ सफर बन चुके हैं। जैसे कोई पुरानी कहानी की किताब हो जिसे समझना अब हमारे लिए जरूरी हो गया है। आज हमारे साथ हैं साइंटिस्ट सी श्री गोविंद नंद कुमार जी, जिन्होंने इस गैलेक्टिक सफर को समझा। तो चलिए जानते हैं गैलेक्टिक आर्कियोलॉजी के बारे में, उस दुनिया से जो हमारी आंखों से दूर है, एक रिसर्च जो कभी पुरानी नहीं होती।
सबसे पहले जानेंगे एरीज यानी आर्यभट्ट रिसर्च इंस्टीट्यूट ऑफ ऑब्जर्वेशनल साइंसेज में साइंटिस्ट सी के पद पर कार्यरत डॉक्टर गोविंद नंद कुमार के बारे में।
Hi, my name is Govind Nanda Kumar. I'm a scientist C in ARIES Nainital, and my educational background is basically BTech in electronics and communication. And then I did a master's in astronomy and astrophysics from Indian Institute of Science and Technology in Trivandrum, followed by a PhD galactic archaeology from the University of Nice, Côte d'Azur in France. And then I did two separate sets of postdocs of 3 years each in Australia and in Lund in Sweden. After that, I joined ARIES as a scientist C.
अब जानेंगे उनका एरिया ऑफ रिसर्च क्या है।
Okay, so my area of research is in the broad field of galactic archaeology. So if you hear about galactic archaeology or archaeology, you will think about fossils. So here in the field of galactic archaeology, we consider stars as a fossils. So we use basically the light from the star, and split them into multiple wavelengths, and from that we can gather the information about the stellar parameters like the temperature, the gravity or the pressure inside the star, and also the chemical composition of the stars. And from that we try to understand how these stars could have formed. So when I say stars are fossils, what it means is that stars retain the chemical composition of the gas from which they formed. So basically it means that the star is 8 into 10 raised to 9 years old, like 8 giga years old, is very old. So it means that when we look at the chemical composition of that particular star, we are looking at the chemical composition of the gas from which the star formed. So basically we are going back into time and understanding how the environment was in the Milky Way when the star formed. So with that, basically what I do is I collect the spectra of the star from both near the sun as well as from the other parts of the galaxy, like the galactic center region. And in the optical wavelength regime, it is not possible. For example, the light that we see, it gets hindered by the dust. So the plane of the galaxy towards the galactic center is full of dust. So the optical light cannot pass through that. So the stars are hidden behind in the optical wavelength regime. So we have to go to another wavelength regime, which is infrared. So infrared light can easily pass through the dust, and we can easily collect that light and use that to split into multiple wavelengths and get this information. And the one of the main issue of the near infrared is that, or the infrared wavelength regime is that, it is a very new area, so that it is not as explored as the optical wavelength regime. So there are lots of lines from the star, absorption lines, that we can gather, which we do not know where they originate from. So these lines basically represent the different elements which from which we can determine the chemical composition of those elements.
साइंटिस्ट गोविंद नंद की ये रिसर्च कॉमन मैन और स्टेम के लिए कैसे यूज़फुल है, आइए जानते हैं.
Yeah, so I would say it is more useful for the STEM community than for a common man. For a common man, it may be of interest for them to know how the Milky Way galaxy evolved, the galaxy in which we live in, how it evolved and formed, and how the sun formed and evolved. So all this information is very interesting for the common man, and it will help them to get curious about these kind of fields and get them to get educated in this field. In the terms of STEM, like I said, near infrared, the wavelength regime that I'm working in, is a very new area. So there are not many instruments which are developed in order to collect the light very efficiently from the star in this wavelength regime. So it will lead to more technological improvements. So we are also can collaborate with the defense. Basically, defense has a lot of infrared instruments. So there are lots of synergy with other industries which can help in development of new instruments which can efficiently use the light from the stars, especially in the near infrared, and use it for my kind of field.
चलिए अब जानते हैं सर की पास्ट, फ्यूचर और प्रेजेंट रिसर्च के बारे में.
So my past research area is broadly in this field of stellar spectroscopy. So I was developing methods in order to determine these parameters of the stars and chemical composition of the stars by identifying good lines which are sensitive to these different parameters in the stellar spectra in the infrared regime. So I have developed that during my postdoc era, and now I'm basically focusing on using the instruments that are available in India. So the kind of instruments that are available for me in India are low resolution instruments, which means that it is not as good quality as the instruments that I have used beforehand, but still it serves the purpose. So what I'm trying to do is, from the knowledge I have gathered from the high resolution data that I got from my previous postdoc experiences, I'm trying to see how we can gather similar kind of information from the low resolution spectra that are available from the instruments in India. And in the future, I would like to build an instrument which is of high resolution in India. Basically, India lacks such a high resolution near infrared instrument, and I would like to contribute to that and maybe use that instrument for more science that can be used to understand how the Milky Way galaxy formed and evolved. So one of the most important thing is that Milky Way is the only galaxy. There are multiple millions and billions of galaxies in the universe. Milky Way is the only galaxy where we can individually resolve the stars, and thus individually resolve the stars. That means that we can study the stars individually, and we can study the different components of the Milky Way, and thus Milky Way act as a template for understanding how the universe evolved, which means that how the galaxies evolved. So Milky Way is a very crucial component in understanding how the universe formed and evolved.
अब जानेंगे सर की इस रिसर्च में इंडिया ग्लोबली कहाँ रैंक करता है.
So, like I said, in my research area, which is with high resolution near infrared instruments, India is lacking such an instrument. But India is making progress in that sector, because we already, in this institute itself, we have an instrument called TANSPEC, which is a low resolution instrument, which has a good capability. But like I said, it is a low resolution, and as a result, I cannot do the same things that I have done with the high resolution spectra that I have worked with. So, and also there is a new telescope that is in plan, which is called the NLOT, National Large Optical Telescope, and many new instruments associated with it, which are also very high resolution. Here itself, in this institute, there is a new instrument that is being planned, or it is almost built, which is called high resolution spectrometer, which is coming upon the Devastal Optical Telescope, and that will also open up a lot of opportunities for me and my future projects.
सर की इस रिसर्च में कंप्यूटर और कंटेम्प्रेरी कौन कौन से देश हैं, आइए जानते हैं.
So Europe has a good network of the countries have come together in Europe in order to build the European Southern Observatory, which is handling the very large telescope, which is a 8-meter telescope. So they have constructed that in Chile, and all these institutes are getting time to observe in that with that instruments. So they are far ahead in some sense. So, like I said, India needs a big, large telescope, and India is doing its own thing by being part of the 30-meter telescope (TMT), which India is very huge part of it. And so, once it is built, we will be able to use those instruments. So we are competing against the whole world more or less. But like in the field of astronomy, the interest varies and the choice of the field varies as the time progresses. For example, right now exoplanet is big thing, especially in US. In Europe, it's also changing to that level. So in my field, stellar spectroscopy is not gathering as much interest. In India, there are very few spectroscopists. It has a huge potential in my perspective to grow and to build my own group.
इंडियन इंडस्ट्री सर की इस रिसर्च से कैसे एसोसिएटेड है, आइए जानते हैं.
So in my field in India, I have just joined, so I am not very sure how much involvement with industries it's happening. But I believe once we start building a new instrument like the one I want to build, we will need definite collaborations with industries to build very high, good technology instruments, especially in the near infrared wavelength regime. So optically, we are pretty good, I believe, which is why the high resolution spectrometer, which is HRS, is being built here. But near infrared still lacks a lot of technology innovations which are required, which need support from the Indian industries.
सर की इस रिसर्च में क्या क्या न्यू फाइंडिंग्स आई हैं, आइए अब इसके बारे में जानते हैं.
There are lots of new findings which has found lots of accreted stars in the Milky Way, which is like the building blocks of the Milky Way. So when we look at the other galaxies in the universe, we see that some of them are kind of merging with each other. So there are signs of like streams of stars which are going into the Milky galaxy's structure. But in the Milky Way, we don't see that as much. But we have seen some of the satellite galaxies like the LMC and the SMC. These are the satellite galaxies of the Milky Way. But within the stars in the Milky Way, there have been many new findings which have found stars which have been accreted in the past. So they act like they are part of the Milky Way, but they have actually been accreted by a big merger process which happened long time ago. So by identifying these stars, scientists have been able to understand what kind of mergers would have happened and at what time range it would have happened and why is it affecting one part of the Milky Way. And then we can use models in order to understand or reciprocate how this Milky Way formed and evolved. So this is a big finding that I find.
अंत में जानेंगे सर की रिसर्च पब्लिकेशन और अवार्ड्स के बारे में.
So I'm happy to say that just yesterday one of my paper was accepted for publication and it is basically put in archive. So which is about the first chemical census of the nuclear star cluster. So nuclear star cluster, which as the name suggests is a cluster of stars in the Milky Way nuclear region, which means the galactic center region. So these stars are a cluster of a lot of stars which are orbiting the black hole of the Milky Way. And we expect that the stars will have a different chemical composition to what we see in the solar neighborhood near the sun. But what we find with the analysis that we have done is that there is not much difference. So the solar neighborhood as well as the inner part of the Milky Way, the nuclear star cluster, do not have much difference in terms of the chemical composition, which means that the Milky Way had a very simple or not exciting kind of evolution from a long time. Okay, thank you. I'm really happy to have this opportunity to talk about my work and to share my work on or what I understood from my work to the general audience, and I thank DST for this. Thank you.
तो अभी आपने सुना हमारा ये खास कार्यक्रम. आशा करती हूँ आपको आज का ये कार्यक्रम पसंद आया होगा. अब हमें दीजिए अनुमति. नमस्कार.